Hello friends, today we are starting exercise number 5.3. To solve the example from this exercise, you should have to know the definition of dot product and all the result related with dot product. Even you should have to know what is the meaning of cross product and all the results which you have got from the definition of cross product. And even you should have to know what is the meaning of direction angle, direction ratios, direction cosines and relation between them. All these things we have seen in last 3 videos. Well, applying these results, now we are starting exercise 5.3. Observe the first example. Here, question is to find out two unit vector, each of which are perpendicular to both u bar and v bar, where value of u bar and v bar is given to us. And question is to find out two unit vector perpendicular to u bar and v bar. Already in cross product we have seen that if we are taking cross product of two vector, means if we are taking cross product of u bar and v bar, so we will get a new vector which is perpendicular to plane of u bar and v bar. Means it is this new vector is perpendicular to plane of u bar and v bar, means it is perpendicular to u bar also and v bar also. Means to find out a vector perpendicular to u bar and v bar, first we have to find out their cross product. Means this will be our first step. Find out the cross product. Now this vector u bar cross v bar is perpendicular to u bar and v bar also, but question is to find out the unit vector perpendicular to u bar and v bar. Already the vector perpendicular to u bar and v bar is known to us. To find out unit vector, so we have to divide it by its magnitude. If we are dividing to u bar plus v bar by its magnitude, we will get a vector along u bar plus v bar, whose magnitude is what? 1. So this is the formula to find out unit vector. If we are dividing to this vector by its magnitude, we will get a unit vector. Let us denote this new unit vector by a cap. So if I am giving here plus or minus, means we are getting two unit vector. One is in the direction of u bar cross v bar and one is in the opposite direction of u bar cross v bar. That plane means what? One flat surface. U bar cross v bar is perpendicular to this plane. If its direction is upward, then minus u bar, this minus means we will get a new vector which is perpendicular to this plane, but it is in the opposite direction. Means in short, we are getting two vector. One is perpendicular to this plane in upward direction and one is in downward direction. Means to find out this unit vector, first find out cross product. Already in the definition we have seen that cross product of two vector is a new vector which is perpendicular to both the vector. So let us try to find out this try to find out the value of u bar cross v bar. Here already we have written the value of u bar and v bar. We are finding now their cross product. So u bar cross v bar. If the vectors are represented in Cartesian form, at that time value of cross product can be found out using determinant. In the first row, write down the basic vector I bar, j bar, k bar. In the second row, write down the coefficient of I cap, j cap, k cap from which vector? U bar. So means here coefficients are 2, 1, minus 2. In the third row, write down the coefficient from next vector v bar, where here coefficients are 1, 2, minus 2, where these coefficients are also called as components along x-axis, y-axis and what? Z-axis. Now let us simplify this determinant. First, keep this I cap as it is. I cap as it is. Delete this column, find out determinant of these four elements. So this product is minus 2 minus this product is minus 4. Minus and this minus will become plus 4. Now here plus j cap is there, so we have to consider here minus j cap because we are finding value of this determinant along first row. Well, now delete this column, try to find out determinant of these four elements. This product is minus 4 minus this product is minus 2. Minus and this minus will become plus 2. Lastly, let us try to find out coefficient of k cap. Now delete this column. So here 4 minus 1 will be equals to 3. 4 minus 1. So this product is 4 minus this product is 1. So let us simplify it. Here 4 minus 2 is 2. 2 into I cap is 2 I cap. Here minus 4 plus 2 is minus 2. Minus 2 into minus will become plus 2. Plus 2 j cap. And here 4 minus 1 is 3. 3 into k cap is 3 k cap. In this way, we have got the value of u bar cross v bar. So now this is the vector which is perpendicular to u bar also and v bar also. Now we have to find out a unit vector. So to find out a unit vector, so therefore unit vector perpendicular to u bar and v bar is, let us denote that unit vector say by e cap is equal to plus or minus. This vector is perpendicular to u bar and v bar. So to find out unit vector perpendicular, to find out unit vector perpendicular to u bar and v bar, divide to this vector by its magnitude, magnitude of u bar cross v bar. So which is equals to, now substitute the value of u bar cross v bar. What is the value of u bar cross v bar? 2i cap plus 2j cap plus 3k cap divided by magnitude of this vector. Magnitude will be equals to under root 2 square plus 2 square plus 3 square. So therefore E cap will be equals to, here plus or minus, keep it as it is. If we are considering plus, we are getting first vector, and if we are considering minus, you are getting second vector. Means in short, we are getting two unit vector here. Now remaining part is just to simplify it. So 2i cap plus 2j cap plus 3k cap in the numerator, keep it as it is. Now observe the denominator very carefully. Square of 2 is 4. Again here square of 2 is 4 and square of 3 is 9. So 4 plus 4, 8. 8 plus 9 will be equals to 17. So here we are getting under root 17. So in this way we have got two unit vector perpendicular to u bar and v bar. So this will be the required answer here. So well, see in the second example, it is given to us that a bar and b bar are two perpendicular vectors, Using this condition, we have to prove that square of magnitude of a bar plus b bar is equal to square of magnitude of a bar minus b bar. So observe what is the given condition here. A bar and b bar, are two perpendicular vectors. It is given to us, and we know that if two vectors are perpendicular, at that time their dot product will be equals to what? 0. This result already we have seen in dot product, that if two vectors are perpendicular, at that time the value of their dot product will be equals to 0. Now using this condition, we will try to show that the value of this left hand side and right hand sides are equal. So first we are considering this left hand side. So now consider the left hand side. So square of magnitude of a bar plus b bar. So which is equals to, let us try to find out value of square of magnitude of a bar plus b bar. In dot product, see we have seen one result that a bar dot a bar will be equals to square of its magnitude. This is one of the important result which you have got in dot product. That dot product of same vector is equal to square of its magnitude, or in other word we can say that square of magnitude means dot product of same vector. So square of magnitude is nothing but dot product of same vector here, which is the vector a bar plus b bar dot a bar plus b bar. So hope you have got it. So dot product of these two same vector is equal to square of its magnitude, or in other word we can say that square of magnitude is nothing but dot product of same vector. So this is one of the important result which you are using from dot product. Now take the dot product of these two brackets. Let us see what we will get here. Here a bar dot a bar. First I am taking dot product of a bar with both the terms in this bracket. A bar dot a bar will be equals to a square, because dot product of same vector is equal to square of its magnitude. If I am not giving here bar, means we are not considering the direction, we are considering only what? Magnitude. What will the second term? A bar dot b bar. So plus a bar dot b bar. Plus, now we are taking dot product of b bar with both the terms in this bracket. So what we'll get here? First term will be b bar dot a bar. B bar dot a bar plus b bar dot b bar will be equals to b square. Now it is given to us that these two vectors are what? Perpendicular to each other. So if these two vectors are perpendicular to each other, means a bar dot b bar is equal to 0, or we can say that b bar dot a bar is equal to 0, or we can say that b bar dot a bar is equal to 0. One and the same thing. So which is equal to a square, keep it as it is, plus. Now this a bar dot b bar can be replaced by its value 0, plus b bar dot a bar can be replaced by 0, keep b square as it is. So here we will get a square, not necessary to write 0, plus b square. Let us denote it by equation number 2. So in this way, we have got the value of square of magnitude of a bar plus b bar is equal to a square plus b square, which is nothing but the value of what? Our left hand side. Now we are trying to find out value of this right hand side using the same method. So, and magnitude of a bar, square of magnitude of a bar minus b bar is equals to, again, square of magnitude means what? Dot product of same vector. Here vectors are a bar minus b bar and a bar minus b bar, and we are taking their dot product, and we, according to this result, dot product of same vector is equal to square of its magnitude. So which is equals to, now take the dot product of these two brackets. First take the dot product of a bar with both the terms in this bracket. So what will get? A bar dot a bar is equal to a square. A bar dot minus b bar is minus a bar dot b bar. Now take the dot product of this minus b bar with both the terms in this bracket. Minus b bar dot a bar is minus b bar dot a bar. Here minus into minus will become plus, and b bar dot b bar will be equals to what? B square. So which is equals to, from equation number first, a bar dot b bar and b bar dot a bar can be replaced by 0. So substitute here, value is equal to 0, here also 0, plus b square as it is. So here remaining terms are a square plus b square. So denoted by, say, next equation, equation number 3. Now what we can observe here from this equation number 2 and equation number 3, right hand sides are equal, and since right hand sides are equal, that's why we can say that these left hand sides are also equal. So from equation second and third, we can say that square of magnitude of a bar plus b bar is equal to square of magnitude of a bar minus b bar, and this is the important condition you should have to know while solving the objective type question, that if two vectors are perpendicular, at that time this condition is satisfying. So this completes the proof here. Well, now see the question number 3. In this question, we have to find out the values of C, so that for all real x, these two vectors makes an obtuse angle. Now here two vectors are given to us. So I have denoted first vector by a bar and second vector by b bar. So now it is given to us that angle between these two vectors is what? Obtuse angle. Using this condition, question is to find out values of C. So we know that, so if angle between two vectors is acute at that time, value of dot product will be what? Positive, greater than 0. If the angle between two vector is 90 degree, means if two vectors are at right angle, or we can say that two vectors are perpendicular, at that time dot product is equal to 0. And if angle between two vector is obtuse, at that time value of dot product is what? Less than 0. All these results we have seen in dot product. Now using this result, I hope you remember this result. What is definition of a bar dot b bar? A bar dot b bar is equals to a b cos theta. Multiplication of three term is there, isn't it? So here first term is magnitude of first vector, means first term is positive. Now second term is what? Magnitude of second vector. Magnitude is length. Length cannot be negative, so we can say that the second number is also positive. Means, and product of two positive number is what? Positive. Now let us discuss about this third number. If theta is acute, means less than 90, at that time cos theta is also what? Positive, and positive into positive number will be positive, means dot product is positive. If angle between two vector is acute, means angle between a bar and b bar is acute. If the angle between a bar and b bar is 90 degree, at that time here replace theta by 90, we know that cos 90 is 0, and 0 into any term will be equals to 0. And last important condition related with what? Obtuse angle. If angle is obtuse, means greater than 90, at that time value of cos theta is what? Negative. Theta lies in second quadrant. If theta is what? Here angle is obtuse angle. In second quadrant cos theta is negative, and negative into positive is what? Negative, means dot product becomes what? Negative if the angle between two vector is what? Obtuse. So here it is given to us that angle between, since a bar and angle between a bar and b bar, angle between a bar and b bar is obtuse, That's why we can say that here a bar dot b bar is less than 0. So this result we are getting from dot product, that if angle between two vectors is obtuse, at that time dot product is negative. Now substitute the value of a bar. What is the value of a bar here? X c I cap minus 6j cap plus 3k cap. Now keep this dot also as it is. Replace b bar by its value, where value of b bar is equal to xi cap plus 2j cap plus 2cxk cap. On keep this inequality and less than 0 as it is. Now let us try to find out dot product of these two vectors. And if you observe here, these two vectors are in terms of I cap, j cap, k cap, means are in Cartesian form. When two vectors are represented in Cartesian form, at that time, while taking dot product, first take the product of coefficient of I cap. If we are taking product of coefficient of I cap, here x into x will be what? X square, and x square into c will be equals to c x square. Now second term is product of coefficient of j cap, that 2 into minus 6 will be equals to minus 12, and last term will be 3 into 2cx, 3 2s are 6. So here we will get 6cx less than 0, keep it as it is. Just simply we have taken dot product of these two vectors. Now if you observe this expression, is it a quadratic equation? Yes, it is quadratic equation in terms of what? X. First let us write down this quadratic equation in standard form. Means first write down the term of x square, so cx square, then write down the term of x, that is 6cx, and lastly write down minus 12 is less than 0, keep it as it is. So already you have studied about quadratic equation in your earlier classes. In 10th standard also you have studied about quadratic equation, but in 11th standard you have studied about what? Quadratic inequalities. Here less than means inequality is there. So one of the important result related with quadratic equation, that if equation is ax square plus bx plus c is less than 0, at that time a is less than 0 and the value of discriminant we are denoting by what? Delta means what? B square minus 4ac. Value of discriminant is also less than 0, and a means coefficient of x square is also less than 0. Remember this inequality you have studied in class 11 in quadratic inequality. So using this we are solving this inequality. Here also one quadratic equation is there, quadratic inequality is there. So and it less than appears, at that time these two conditions are satisfied. So therefore here a is less than 0, a means coefficient of x square. Here coefficient of x square is what? C. So here we can say that c is less than 0, and b square minus delta means what? Discriminant. Its value is b square minus 4ac. B means what? Coefficient of x. What is coefficient of x here? 6c whole bracket square minus 4a. A means c here into c. C means here minus 12 is less than 0, keep it as it is. So therefore c is less than 0, and square of 6c will be equals to 36c square, minus into minus will become plus, and 4 12s are 48, c is less than 0, keep it as it is. So therefore c is less than 0, and if you will observe both the terms, can I take 12c common from these two terms? If we are taking 12c common, so here remaining term will be 12 3s are 36, so 3c will be the remaining term, and here 12 4s are, means here remaining term is plus 4 is less than 0. Now try to understand here, keep this first term as it is, c is less than 0 as it is. If you will observe here, product of 1, 2 and 3 term is there, isn't it? So product of 1, 2, 3, 3 term is there, and this product is what? Less than 0. When we can say that product is less than 0? If at least, if exactly one term will be negative here, at that time only we can say that product is what? Negative. Less than 0 means negative. But here we can observe that first term is what? Positive. 12 is positive number. Now 12 is positive. Forget about now 12. Now product is negative means either c is negative or this term is negative. Because if product is negative, if two terms are of what? Unlike sign. Means if one is positive, other is negative. Means if first is positive, second is negative. Or if second is negative, then if first term is negative and second term is positive, at that time we can say that product is what? Negative. Or if first term is positive, then second term is negative. If product is negative, means these conditions are satisfying. Here product of these two terms is negative, means if either first term is negative, means definitely second term should be what? Positive. Or if first term is positive, then definitely we can say that second term is what? Negative. Getting it? If product of two number is negative, means both the numbers are of what? Unlike sign. And if they are of like sign, then definitely product will be what? Positive. As this time this product is negative, means these two numbers are of unlike sign. Now already here what result we have got? C is less than 0, means this C is negative. If C is negative, means definitely this number is what? Positive. Means here we can say that 3C plus 4 is positive, means greater than 0. Hope you have got it. Product of three number is what? Negative. We know that product is negative if one number will be what? Negative here. But first number is what? Positive. Second number is what? Negative, means definitely third number is positive. Then and then only this product will be what? Negative. So hope you have got this condition. So now let us simplify it. So therefore C is less than 0, keep it as it is. Simplifying it, 3C plus 4 on this side will become minus 4. So therefore C is less than 0 and C is, take 3 on this side, 3 is multiplied, on this side it will get divided. Now here what result we have got here? Now here C is less than 0, so first consider 0 here, and which is the second number? Minus 4 by 3. Definitely minus 4 by 3 is on the left hand side of 0. Now our first condition says that C is what? Less than 0. C is less than 0 means C lies on the left hand side of 0. And here what we are getting? C is greater than minus 4 by 3. C is greater than minus 4 by 3 means greater number will be always on what? Right hand side. So C will be greater than what? Minus 4 by 3. It is given to us. Its meaning is that if we are combining these two result, we can say that C belongs to minus 4 by 3 and what? 0. Means C takes the values in between minus 4 by 3 and 0, excluding this notation is called as what? Open interval. Open interval means what? C takes the values in between these two number, excluding these two number. So here definitely 0 is also not included and minus 4 by 3 is also not included. That's why we can say that C takes the values in this interval. So how many numbers are there in this interval? Infinite. All these numbers satisfies which condition? That dot product of these two vector will be what? Positive. In this way we have got the values of C, so that the dot product of these two numbers will be what? Sorry, angle between these two numbers will be what? Obtuse. So if C takes the values in this interval, at that time we can say that angle between these two vector is what? Obtuse angle. So these are the required values of C. In the next video, we will discuss again remaining next examples, next 2-3 examples from this exercise.